So this example is you have 15,600 invested for 2.5 years at a continuous compounding rate. After the 2.5 years, 7,000 Rand is added to the investment and it's reinvested for a further 5 years at 14% compounded quarterly, where it grows to 51,772 Rand and 96 cents. And it asks us, what was the initial interest rate? So straight away, you can see that there's a reinvestment happening in this problem. And when there's a reinvestment happening, essentially you have like multiple parts occurring in your calculations because information is changing. And the easiest way to handle the information changing is to draw a timeline. So that's what we're going to do. We're going to start drawing a timeline. We're going to fill it in step by step in stages, just to show you how you can, visually represent what is happening, and it will make it clearer to you how to do the calculations. So we're going to start off by just creating a timeline with a starting time and a finishing time. So standard T0 and TF for starting and finishing. And then we're going to slowly start putting information on it, and you're going to see how we build up the information on our timeline. So we start off with the 15,600 Rand invested at the beginning. So we have a present value at T0 is equal to 15,600. And it says it's invested for 2.5 years. So you're like, okay, let's just indicate that this is 2.5 years. Now, you don't have to be pretty with the timeline. It's just there to give you a rough sketch idea of what's going on. And during this 2.5 years, it's invested at a continuous compounding rate. But they don't tell us what the continuous compounding rate is. So let's just fill it in as J is equal to some percentage PACC. Then it says, after the 2.5 years, 7,000 Rand is added to the investment, and it's reinvested for a further 5 years. So at this time period here, after the 2.5 years, we're going to call it T hashtag at the moment, but there is a specific subscript that is going to go in there. We have a future value occurring from this first part, because what we're going to do is we're going to take whatever we get from this first part, add 7,000 Rand to it, and then reinvest it. So we're going to get some future value. We don't know what that future value is. Then we're going to reinvest it for part 2. Now, I like just using colors because it makes it a little bit clearer in your brain, like what is part 1, part 2, part 3, etc. So when we reinvest it, we have a present value is equal to the future value from that first part plus the 7,000. So that's going to be reinvested. And it's going to occur, like at the exact same time as when part 1 ends, part 2 is going to take over. So this part of the timeline is like the pink part to indicate, so to indicate part 2, we have, this pink line occurring at the moment. And this one is going to take 5 years. So it's reinvested for 5 years. So we're going to be okay. This is 5 years. And it's reinvested at 14% per annum compounded quarterly. So we have that J is equal to 14% per annum compounded quarterly, where it grows to 51,772 Rand and 96 cents. So at this T final spot, it's going to grow. So it's going to have a future value of 51,772 Rand and 96 cents. So you can see pretty clearly that there are 2 parts to this. There's the green part and then there's the pink part, to see the difference between the 2 of them. Now what we're going to do is we're just going to write down everything that we know for part 1 and part 2 underneath the timeline, because that's going to help us figure out, the order of how we need to solve things. Some people can see it straight away and they'll be like, oh, well, we have to do part 2 first because we have more information for part 2. And once we have the information for part 2, we can then do part 1. But not everyone is that lucky. So we're going to follow the approach like if you get stuck or if you're not sure. So to do the information for the 2 parts, we're going to first represent our time period in terms of T subscript N. So you'll see what we did here. We had T0, T hashtag, and T final. We're now going to give them proper values. So we're going to have like a TN, and our N subscript is going to be represented by the units of our smallest compounding, by the smallest compounding period. And the reason why we're going to choose the smallest compounding period to break up our time in is so that our N is always going to be an integer or a whole number. So, whole number. So for example, that 2.5 years, we don't want to say T2.5. That's kind of messy. We would prefer to look at the case of the fact that quarters are smaller than years in regards to, your continuous compounding units are years and your quarterly compounding units are quarters. We prefer to write our timeline in terms of the smallest compounding unit, which is quarters in this case, so that it's a nice, pretty representation with only whole numbers occurring. So when we look at our timeline and we go through the process, we are going to represent this T hashtag with the hashtag in terms of the quarters at that moment in time. So we need to rewrite 2.5 years in quarters. So how do we do that? We just say 2.5 times our 4 gives us 10 quarters. Now we have our part 1, and I'm going to keep writing it in green so you can see the connection. Starts at T0, ends at T10, and that's representing the 2.5 years. Then our part 2, it starts at T10 and it's going to continue for 5 years. So that's 5 times by 4 gives us 20 quarters. So it continues to T30. So we write down the information we have from T0 to T10 and then T10 to T30. We don't change our units for this subscript N that we're looking at when we're writing this kind of stuff. Okay. Now we're going to write down everything we know for the 2 parts. So in part 1, we have our present value is equal to 15,600. And we can say that it's the present value at T0. Just to, make it clear for us what's going on. We could have also said the present value of part 1, but I'm going to try and keep consistent with using the T to represent the time and where everything is at that moment in time. So we have our PV at T0. We also have our N, and our N, when we're doing our calculations, needs to coincide with our interest rates compounding. So it's continuous compounding. So we know it's 10 quarters because we could read it straight from this T0 and T10. We go 10 minus 0 gives us 10. So we know it's 10 quarters. We also know it's 2.5 years. But if we just read it from, the information we were given there, we would have to just divide it by 4 to get it in years to correspond for our interest rates. So 2.5 years. When we do our calculations, that N needs to match our interest compounding periods for that section. So just be careful. There's a difference between what we're representing here and what we use in our calculation. So this is just like a broad timeline situation. This is for an actual calculation. Okay, so let's continue with the information that we know. We have 2.5 years. We don't have anything else. So we currently still need the future value at T10, and we still need the interest. So we have 2 unknowns, and that's going to help us, particularly if we do get confused. If we have 2 unknowns, this is not the part we need to start with. So let's just write down everything we know for part 2. So let's just bring that timeline back into display for us and write down everything that we know for part 2. So we have a T10 to T30 for our time period. That's 10, and then you have T30. 30 sits over there. We have our PV at T10 is equal to our future value at T10 plus 7,000 Rand. What else do we have? We have that the interest, the J, is 14% per annum, compounded quarterly. We have our N. Our N is 20 quarters. And we can leave it as 20 quarters because the compounding is quarterly. So the quarterly there and the quarters there coincide with each other, which is the correct approach. We also have that our future value at T30 is equal to 51,772.96. What we don't have and what we're going to look for is the present value at T10 so that we can solve for the future value at T10 so we can use it in part 1 to work out our normal interest rate there. So in regards to this, we have J, we have N, we have the future value. We then technically only have the one unknown, the present value. So that's, we work out the present value, and then we're like, oh wait, we can actually use the present value to work out our future value in part 1. So just a reminder, in part 1, our future value is equal to the present value at T10 minus 7,000. So that's another hint that we needed information from part 2 for part 1. Okay, what are we missing? We're just missing writing down the M, which is our CY and PY. So our M here is 4. It's just something that we should acknowledge. So if we do it on our financial calculator, we put in our compounding periods as 4. And when we do it on our formula, we can acknowledge that. So we're going to use our financial calculator in this case. But before that, I'm just going to remind us that if we do it using our formula, what we actually have to convert. So remember, our formula for normal compound interest is FV is equal to PV 1 plus IM to the power of N, where the units of M and N need to coincide. And it's IM, which is J divided by M. So we'd have to convert to the effective interest rate and put it in decimal fraction notation for our formula. So we would still need to convert that to I4 for our formula. However, we're using our financial calculator, and our financial calculator uses the normal interest rate. And we can use our financial calculator in part 2 because it is compounding interest. It's not continuous compounding. So if we were going to use our financial calculator, the recipe we would follow is second function, CA. Remember that's stage 1. Stage 2 is putting in our compounding periods. So second function, PY, 4ENT. Check our CY coincides and clear our screen. 2. And then we put down everything that we know. And we want the present value to come out as positive, preferably. So when we store it in our calculator, it's a positive value. But that's not necessarily needed. We could say, hey, we're going to invest money, so our present value is going to be negative, and that means when we get the money back, it's going to be positive. So let's do it that way. Let's just do it the logical, like you look at your question and you go approach it. So that means we have 51,772 Rand and 96 cents future value, 14 IY, and 20 N. And that's our stage 3. And we asked it to compute our PV. And if it does that, we're going to get a value of minus 26019.32. And we're going to store this in our calculator because we need it for our part 1 calculations. So we're going to actually say store and indicate whichever variable we want to store it in. I choose variable A. Store MRT. We could restore this so we can actually say plus minus recall MRT and then store it again so it's positive. Or we can just acknowledge the fact that when it's stored as a negative value. So just a reminder, when we store it like this, in this recipe, the way that we approached it, it is stored as a negative value. And that's going to have implications on when we recall it from our calculator. Okay, so now we have stored that value in our variable A on our calculator. We can now go back to, our part 1, which is the T0 to T10. And we can now actually find what our future value is there. So we can first find our future value. So our future value at T10 is equal to our present value if it was a positive value. So we will be like plus minus recall that variable minus 7,000. So we recalling the present value from the pink part. And the reason why we have the plus minus, because it was stored as negative. And what we can do now, we can just store this value in. So we'll just say STO, and we use the next variable. We use variable B. So now we have our future value stored on our financial calculator. Now we need to consider the fact that this part 1 is continuous compounding. And when you have continuous compounding, you have to use the formula. So a reminder of what the formula is, it's the future value is equal to the present value, e to the jn. And we are looking to solve for j. So solve for j, which means we need to make j the subject of the formula. So that's going to be your future value over your present value is equal to ejn. We're going to ln both sides. And that's going to give us ln ejn. We're going to use our log rules, and that's going to be jn ln e ln fv over pv. Ln e is just equal to 1, so that can pretty much just go away. So now we have j is equal to ln the future value over the present value divided by n. And now we can just put in our values into our financial calculator. So that's going to be ln, and we're going to be like recall future value, and it's going to be a positive value. We've stored it as a positive value, so we just recall bond it. And it's recall bond because we stored it at the variable b place, divided by, and this is our 15,600, and then our n, which is 2.5. And if we go ahead and work that out, we are going to get technically 0.0793, etc. And in percentage notations, if we had to discuss it with somebody, it's going to be 7.93% per annum continuously compounded. So just a reminder through the entire process, let's just zoom out so we can see all the working out we did here. We started with our word problem, and we drew up a timeline to just represent our word problem because that helped clear up, what belonged to where. We then represented our time periods with the smallest compounding period rate, so it will always be integers. So we left with none of the awkward, like 1.5s, etc. And that's how we represented, our part 1 and our part 2. Then we wrote down all the information we had for our part 1 and part 2 in this case. You will have questions that will have like part 3, part 4, part 5. Again, same method, just extended and more information you have to go through. So we wrote down everything that we know. So that was, this part here and this part here. And then we looked to see which one only had one unknown, because then we could solve for that unknown. So that was, part 2 in our case. We only had PV was unknown, so we could solve for our PV. And we could also see, if we wrote down all information correctly, that we needed information from that part 2, that, T10 to T30 part, to be able to solve for our part 1, which is our T0 to T10 part. So that was another way that we could see, we need to solve part 2 first because we need part 2's information to finish our part 1. So then we go ahead and do the solving of whichever sections in whichever order we need to do it in. And we take note that particularly when we have the financial calculator, with our compound interest, we can do it. But if it's continuous compounding, we have to use the formula. So we had the situation of, for our part 2, we could just use the financial calculator recipe to go ahead and solve it. And we acknowledge the fact that we need to be very, very careful when we're storing our numbers to acknowledge the negatives and positives in them, because they're going to affect it when we recall those variables later on. Going to affect our calculations. So that was that situation where we had the plus minus in our recall, so we get the proper answer coming out. So we just have to be careful of that and take note of that and go through our processes, making sure that we're using the correct version of the variables. Then we just go ahead and finish our solving and we get our answer. Affected